So we come to the end of this MOOC, and it is time to acknowledge the contributions that many have made to the making of the MOOC, some of them wittingly, some of them unwittingly. The key contributions, of course, come from Peter Hoare, who wrote this little book that we have been using in these lectures. So Peter Hoare is lecturer at Oxford University, and he has written a book that I have bought in vast quantities to redistribute among my students over the last 15 years or so. He has made a new edition, of which you see the cover page, which actually has come out this week. This is now in June 2015 that I'm speaking, and therefore you should be able to get it from your favorite local librarian. I should say that Peter Hoare deserves a great deal of credit for this book. He came from the world of EPR, electron paramagnetic resonance, and learned enough about magnetic resonance of nuclei to pick up the best examples that I am aware of applications of relaxation, of chemical exchange, of biomolecules, and all of these different branches of magnetic resonance that are discussed in the book. So the next person I would like to acknowledge is Samy Janin. He is here in Lausanne, and he has also recorded some videos that are part of the MOOC. In fact, the idea that these videos would give you some feeling of more recent developments and modern applications that go beyond the boundaries of Peter Hoare's elementary text. I should also acknowledge the contributions of Basile Vichou. He is a senior graduate student here, almost coming towards his PhD at the École Polytechnique Fédérale de Lausanne, and he has not been seen on the videos, but he is responsible for the preparation of the PowerPoint material that you have seen, and also for uploading questions and multiple answers on the website of the MOOC system. Finally, I should say that there is an entire team at the Laboratoire de Résonance Magnétique Nucléaire Biomoléculaire who have one way or another contributed to making this MOOC possible, and you have seen some of the laboratory in the teaser. Here in the Learning Center of the EPFL, there are at least two people who have made this possible. Matthew Goodman has done all of the editing, and I have seen some of it, and I know that it is a very difficult task, and he is very proficient. And Gwenaël Bocquet has overseen the entire effort and coordinated whatever needs to be coordinated. So the team that makes up the Laboratoire de Résonance Magnétique Nucléaire Biomoléculaire here at the École Polytechnique Fédérale de Lausanne, of course, changes from year to year, but I've taken this picture from a few years ago because it shows a nice collection of activities and specialties. First of all, in the first row, you see Diego Carnevale, who is an expert of solid-state NMR and recently moved to the University of Neuchâtel. Then behind him, Samy Janin in a white shirt. You know him because he contributed to the MOOC. In front of him, Pascal Miéville, who is now at the staff of EPFL, did his PhD in our group. Then myself. Next to me, Simone Uzega in a red shirt. He is now at the EAWAG. Kneeling in front of him is Roberto Burato, who is about to obtain his PhD here in Lausanne. It is not necessarily to kneel to get a PhD, but he took some precautions. Then standing behind him is Jonas Milani, who you will see, or you may have seen in the teaser, where he is showing how the samples are put into the spectrometer. And in a dark red shirt, there is Nicola Salvi, who did his PhD in our group some years ago, partly involved in new techniques for screening of drugs, and after his PhD went off to Harvard Medical School for a year, and he is now in Grenoble at the Institut de Biologie Structurale. On the second row, you see somewhat in the dark Takuya Segawa, who finished his PhD at Lausanne and is now in Zurich, working on electron spin resonance. Then the tallest figure of all is the one of Veronika Wietstum, who seems like she descended from heaven through this circular window that looks like a bit like a halo above her head. And she is now doing MRI in Bern at the Inselspital and also in Solothurn or Soleure, northern Switzerland. Next to her is Mark Caporini, who is an American postdoc who, after a few years in Lausanne, returned to Boston and became involved in the American branch of the Bruker Company, and then recently moved into a company that makes biomolecules. And finally, Aurélien Bornet, who got his PhD a few weeks ago and will stay in our lab a bit longer to do dissolution DNP. Now there is a smaller sub-team, partly composed of the same people, that is specifically active in the field of dissolution dynamic nuclear polarization. You see them here in front of a machine that can cool samples to 1.2 Kelvin. Now that's very cold, as you may realize, and that can irradiate these samples by microwave with about 50 milliwatts. And you see on the right side sitting Sami Janin, who is rightly proud of this machine because he worked on it for many years and developed it virtually from scratch with all the whistles and bells and the pumps and the microwave sources and the waveguides and everything else. Standing in the middle is Basile Vuichou. He is also rightly proud of his achievements, and you can see that he is not ashamed of what he did. And behind him is Jonas Milani, who made many interesting contributions to this machine, in particular a magnetic tunnel that runs just above his head, through which we can transfer samples from the polarizer, which you see in this laboratory, to another magnet which is in the laboratory behind the wall. Now to the left of Basile you see Lyndon Emsley, who is going to be my successor here at EPFL. In fact, he has just been installed here on June 1st, about 11 days ago, as of today, together with two people that joined him on a trip from the École Normale Supérieure in Lyon. So I should also acknowledge the fact that I spend most of my time in Paris and only come to Lausanne every other week to give lectures and record MOOCs. And in Paris, I'm in charge of a team which is partly at the École Normale Supérieure and partly at the Université Pierre-Marie Curie. And as you can see, we meet in actually at regular intervals. About once a week, we have a group seminar. And you see some of the members here freezing in the February cold at the foot of the administration building of the UPMC. Actually, many of the important people in the group are missing. They are mentioned on the list on the right-hand side. And the whole thing is a very lively environment which stimulates and generates much interesting research, both in methodology as well as in biomolecular applications and solid-state methods. Now, finally, I would like to acknowledge, so to speak, the rest of the world, and I suggest starting with a statement with a quotation from the Talmud. And I should say that Hebrew is not one of the many languages that I tried to learn at school and after that, but I had a friend who tried to teach me how to pronounce this. And what I remember of this lesson is roughly like this: Mimorai iskalti yoter mirabotai avalarov yamadeti mitalmidai. Whether my Hebrew friends or Hebrew-speaking friends understand that or not, I can give you an English translation or some attempt to translate this into English. From my teachers have I been enlightened, more from my colleagues, but most I have learned from my pupils. Now, this statement comes from the Talmud and was brought to my attention by Dr. Dietza Pines, who is at the University of California at Berkeley, where I spent a few months as a visiting professor. Now, teachers, there are of course many. I could think of my PhD advisor, Ray Freeman. I could think of Peter Hoare. I could think of Richard Ernst and of Kurt Wüttrich in Zurich, with whom I did many interesting things, or at least things that I found interesting. I can think of Bob Griffin at MIT, who taught me much about DNP and about solid-state NMR. I can think of Regitze Wold and Bob Wold at UCSD, with whom I did a postdoc and I learned a great deal about relaxation from them. There are many teachers in the narrow sense of the word, but in fact there are many more, of course. There's a vast community of people whom we come across when reading papers and studying brilliant ideas that have been developed over the last 50 years or so. The colleagues, living colleagues, are quite numerous. I'm not only thinking of my immediate environment, who are doing chemistry or physics or biology, and of course we learn a lot from them, but there are also people who come to meetings, and in my field there are so many meetings that you can almost move from meeting to meeting without ever going home. Some of these meetings are held in Europe. There is a series that is called EuroMAR, for European Magnetic Resonance, of which I've been the founding chair of the Board of Trustees for the first 6 years that this organization was running. And it's now going to be held in this year, in July. It will be held in Prague in the Czech Republic. And these meetings, which group about 500, 600, 700 colleagues, are always an opportunity to learn from them and to be stimulated and to discover new fields. But most of all, I learn from my students, one lecturing, one trying to explain things in a classroom, one trying to advise my PhD students, one revising the drafts of papers they may have produced, one arguing about the best graphical material on how to present their results in the most seductive way. All of these things are interactive between my students and myself. And I believe that one learns most from students, much more so than from the teachers, something that was already realized at the time that the Talmud was written.